So today, we're talking about one of the cleanest, most powerful sources of renewable energy on the entire planet. It's everywhere, right? Invisible, but absolutely immense. And we're going to figure out exactly how we can tap into its incredible power. Okay, get this. Every single day, the wind generates enough kinetic energy to produce about 35 times more electricity than all of humanity uses. Yeah, you heard that right. That is a mind-boggling amount of power, and it's up for grabs every single day. And here's the kicker. Unlike coal or oil, this resource is completely renewed day in and day out. So that leads us to the big question for today. How do we actually harness this incredible invisible force? And could we one day power our entire world with it? Okay, so here's how we're going to break it down. We'll start with the wind's massive potential, then get into how a simple breeze becomes electricity. We'll look at the clever design of the turbine, its real-world power, the challenges it's up against, and finally, what the future holds for wind energy. All right, first up, that untapped potential. I mean, that 35x number really puts it all into perspective, doesn't it? We are literally surrounded by a huge, constantly replenishing source of energy. It's a whole different ballgame from the fossil fuels we've been relying on for so long. Okay, so how do we actually turn a simple breeze into the electricity that powers our phones and our homes? The core idea is actually super simple, and it's been around for centuries. It's all about changing energy from one form into another. It really all boils down to three key steps. First, you've got the wind's kinetic energy, the energy of movement, pushing on the turbine's blades. This gets converted into rotational energy as those blades spin around. And that spinning motion turns a generator, and boom, you've got the electrical energy that powers our lives. But, how do you squeeze every last drop of energy out of that wind? Well, it all comes down to designing the absolute perfect turbine. And there are really three key things that decide how much energy a single turbine can crank out. First off, you've got the orientation of the turbine. Now, vertical axis turbines can catch wind from any direction, which sounds great, but they're just not that efficient. The horizontal axis ones, the ones we all picture that look like giant propellers, they're way more efficient because they can turn to face the wind head on. Okay, so how do these things always know where to point? Well, it's a process called yawing. Back in the days, someone had to turn old windmills by hand. But now, it's all high-tech and automated. Wind sensors and computers are constantly adjusting the turbine to face directly into the wind, making sure it captures as much energy as possible. And the blades themselves, this is where the design gets really, really cool. They aren't flat at all, they're curved, just like an airplane wing. As wind rushes over that curved surface, it creates a little pocket of low pressure. This generates lift, which actually pulls the blade, driving the rotation. This is so powerful that, get this, the tips of the largest blades can travel at over 200 miles per hour. That is faster than a Formula One race car. Yeah, these blades are absolute marvels of engineering. They're made of these super strong layers of fiberglass and resin, and they're built to last for over 20 years. They have to put up with everything: blistering sun, pouring rain, and even lightning strikes. And the last piece of the design puzzle? Height. As a rule, the higher up you go, the faster and more consistent the wind is. So to tap into that better wind, we build these things to be incredibly tall, often soaring well over 100 meters into the sky. Okay, so we've got these super tall, super smart turbines that are always facing the wind. But what does that actually mean in terms of power for you and me? Let's look at the numbers. So just one big turbine, just one, can generate enough electricity in a year to power 750 American homes. That's a single machine powering an entire neighborhood. But of course, turbines almost never work alone. Put 200 of them together in a wind farm, and they could power over 150,000 American homes for a whole year. Suddenly, you're powering a whole city. And the tech just keeps getting bigger and better, especially out at sea, where the winds are the strongest. The largest wind turbine ever built has a rotor that's 220 meters wide. Think about that. One single machine can power 16,000 European households for a year. Incredible. All right, as amazing as all this sounds, it's not all smooth sailing. Wind power has its own challenges, its own headwinds, you could say. First up, there's a hard limit baked right into the laws of physics. It's called Betz's law, and it basically says a turbine can only ever capture, at most, 59.3% of the wind's energy. And why is that? Well, think about it. If a turbine grabbed 100% of the energy, the air would just stop, dead, right behind it. That can't happen, right? The wind has to keep moving. And beyond the physics, there are some more practical hurdles. For some people, the turbines mess up a beautiful view. More practically, let's be real, the wind doesn't blow all the time. That makes it what we call an intermittent power source, which can be tricky for our electrical grids that need power 24/7. But hey, even with those headwinds, the future for wind power looks incredibly bright. So let's talk about where we're headed. And this is really the key takeaway here. Even with those challenges, modern wind turbines have already made wind energy one of the most efficient and cheapest sources of electricity out there. I mean, that's not some far-off dream, that's what's happening right now. You can already see its impact growing all around us. It's providing essential energy to communities all over the world, and it's a steady source of income for farmers who lease their land for turbines. Plus, that whole wind isn't always blowing problem, with better forecasting and new energy storage solutions, it's becoming less and less of an issue every single year. So all of this leaves us with one big question to think about. With all this amazing progress and all this potential, as we push for a cleaner future, could wind power really be the key that blows all our energy problems away?